Okay. Cool. Good to go. Well, welcome guys to our latest Best of the Best webinar hosted by Novedge. And today, this is going to be our first webinar of 2013, and hopefully we're not going to have anything crazy happen technically. So, all right. So for episode 62, we have a preview of RealFlow 2013, a fluid revolution, and this is hosted by Gustavo Sanchez. Since the first previews and release of RealFlow's large-scale fluid solver, Hybrudo 2, I hope I pronounced that correctly, at the beginning of the year, the industry has eagerly anticipated the release of RealFlow 2013. This webinar will guide you through some of the major new features and changes that you can expect to find in the latest and greatest version of NextLimit's cutting-edge fluid simulation technology. Now, here to talk about RealFlow is NextLimit's own product manager, Gustavo Sanchez.
Hello, everyone.
Yeah, see there, Gustavo Sanchez, real person. So this is good. Gustavo has over 10 years of experience in the industry. He has worked with major post-production companies in both London and Madrid. He joined NextLimit in 2008, and he continues to be the RealFlow product manager since May 2011. So before we really kick off, and as the leading online software design store, we pretty much have the best prices around. This is the product page. This is the latest product that we have for RealFlow right now. So RealFlow 2013 isn't out. But if you want to get the latest version of RealFlow, you can visit our product page at Novedge. As the leading online design software store, we pretty much have the best prices around, and it is available. RealFlow 2012 is available as digital delivery in the United States only, and pay zero sales tax. So if you have any questions, feel free to speak with our sales specialist, Bob, at bob@novedge.com. In addition, you can be sure that when RealFlow 2013 is out, we'll be working with NextLimit and Gustavo to make it a part of our catalog. Okay, and also we've created at Novedge 3 online communities as that online place where you can collaborate, communicate with other like-minded professionals. At our communities, we scour the internet for the latest industry buzz to share with you guys. So furthermore, we encourage the community members to participate in the discussion. The process to sign up is a breeze, and with that you have access to a weekly community newsletter where we break down the week's most interesting industry headlines. So for access to discussions that matter, sign up and register today. And I want to talk about what we have upcoming in our next webinar, episode 63. Get a sneak peek at Cinema 4D Release 14's most powerful new features. From fast and intuitive sculpting tools, enhanced dynamics, new camera tools, and many others. Whether you are a visualization artist, motion designer, illustrator, or animator, you'll find something to love about Release 14. Maxwell President and CEO Paul Babb will be presenting this upcoming webinar live. And this will be an excellent opportunity for those who are interested to learn about the new changes and the features. So send your burning questions in. Registration is free, but space is limited. So for more information on how to sign up, check it out at novedge.com/webinar/63. And going forward, we're trying this new thing where you can interact with us live. If you have any questions for going forward for this webinar or any upcoming webinars, type in your question and put in the hashtag NovedgeWebinar. We will respond. Aurora will be there to respond live if and when she can at Novedge Store at our Twitter account. So if you have any questions, do that. The presentation today's presentation will be about 40 minutes long, and in just a bit, Gustavo will take over the rest of the presentation. I'll stop talking. If you have any questions at any time during the presentation, please post them into the chat window so that we can answer them live during the Q&A session. All right, and not this slide. All right, so I will switch over the presenter to Gustavo right now. Gustavo, can you hear me?
Yes, I can. Can you hear me?
Yes, and here we are. In 3 seconds, I will switch you to make you the presenter. All right?
Okay.
All right, here we go.
Ooh. All right, guys. Hello from cold Madrid. Thank you, Kevin, for the introduction. I'm recording this today from home, so if you hear in the background two little monkeys, this will be my daughters, just so you're aware of the noises, if they are any. We're here today to show you a technical preview of what's coming with RealFlow in a couple of months' time. For us, this, as the title says, is a fluid revolution, also an evolution in the product, but there are way too many changes in this one to make it one of the best versions ever of RealFlow. So to see a bit where we're coming from, I'm going to quickly show you something that we haven't shown many times, but since this is Next Limit's 15th anniversary, I thought it would be good to show this little clip. This was the first ever simulation produced with RealFlow, and this is just 1,000 particles simulated in a machine. I believe Victor Gonzalez, the owner and creator, one of the creators of RealFlow, mentioned that it was like an overnight on a Pentium 4 machine. This is where we're coming from 15 years ago. Now we are producing massive amount of data, and I'm pretty sure you have seen already the huge simulation that we are capable of with this latest version. Also, since many people believe or doesn't really understand the whole concept of RealFlow, I want to quickly show you what RealFlow ecosystem, so to speak, is, where we get like the GUI, where the user produces most of the simulations. Then there are the RealFlow nodes, which are the command lines, where you can speed up things by sending chunks of your simulation or different wedges, and in the case of hybrid, different secondary elements, to get simulated on a farm over multiple machines, and as I said, it will speed up time. And then there is also the render kit technology that we introduced a few years back to help with meshing at render time mainly. So when you think RealFlow, don't think only in a single standalone product that will be doing everything. Just think globally in the whole pipeline, where you interact with your 3D package and RealFlow by using the simulation nodes in your farm, and also the render kit plugin that hook up in your 3D package. So without further delay, let's start with the main features in this wonderful version that we have produced for you. Hybrid 2 is probably the most exciting one for all the users, and it will bring, hopefully, we expect this to be the definitive version for RealFlow to achieve the large-scale simulations. And we have two main elements inside Hybrid 2. One is HiFlip, which is our first flip solver implemented inside RealFlow. And why is it important to have a flip solver? Main reason is it doesn't have any bounciness, which was partly one of the reasons that Hybrid 1 wasn't that widely adopted. And the other one is that flip solver can go as low as 1 substep per frame, so simulations will run pretty fast and they will be pretty stable. And then we also have the high SPA, which is what we call the secondary elements that we're going to be outputting from the base of the simulation that we will be creating with HiFlip. And really important, we will be trying to keep as much as we can, and I can assure you that if you know how to use Hybrid in the first versions, you will easily move into Hybrid 2. I'm going to show you now some of the videos that you may have seen already, just to illustrate how much detail we can get and how fast this can run. The machines where we test this in the office are not huge machines. They are normal i7 machines with 12 gigabytes of RAM. And simulations can go crazy in terms of number of particles. We have even managed to produce recently one that unfortunately I cannot show you, but it goes over 400 million particles in a single simulation. But as I said, the level of detail that this solver allows us, and the complexity of the interaction between the simulated fluids and the animation, it's really impressive, at least we hope that everybody will be happy with the results that this new iteration on Hybrido will give them. See that we also keep the dual connection between the rigid body solution inside RealFlow and the fluids. And this particular simulation we really like. By the way, all or pretty much all of these simulations have been done by Luis Miguel Mora, which is, you may know him for his blog. He was one of our colleagues in the office. This one is pretty cool as well because of the interaction. Let me go back one sec because I think let's go back again. I want to show you especially this one. You find it is the one with this one. It's pretty cool the way that the water interacts with the fans and all the detail that gets produced from there and till the very end, where we get 126 million particles and tons of detail that doesn't get lost. And we will see that since we're producing this in the base of the simulation, this is very important. This is just the base of the simulation. Imagine all the detail that we're going to be having on top of this. We're going to have secondary elements in the form of splashes, foam, mist, displacement. So these simulations will be amazing in terms of detail because just from the base of the solver we get this quality. We will be running this on a single box, but then all the secondary elements that you may imagine that you're going to be putting on top of this can be split into different boxes using RealFlow nodes in your farm. And to the next topic, same workflow. I'm going to quickly show you how things were done in 2012 and how things will be done now in 2013 in a minute. But before that, we will move to the next main feature because that will link one with the other. And the next feature, and we consider this one to be as important, if not more important even than the Hybrido tool at some extent, which is the adoption of nodal systems inside RealFlow. And many people were asking for this to be happening ages ago, and we didn't get to it until now because now is the right time for us to do it. And we are adding nodal systems inside RealFlow at two different levels. One is at the scene setup level, which is the relationship nodes, and the other one is the simulation graphs and batch graph nodes, which are kind of a visual programming type of system. Let's quickly open RealFlow so you can know what I'm talking about. I'm going to open first RealFlow 2012 and quickly show you how things were done in 2012. You know the interface has a nodes panel, global and exclusive links. So for instance, doing a simple thing like circle emitter, adding some force like gravity, putting some collision object like a plane, and simply hitting simulate. Let's say simple. If we hit simulate 3 clicks, we have something running and it works. So it's pretty simple, very easy to pick up. Everything gets connected to this pond here, or got connected in 2012, where everything was connected with everything. That wasn't probably the most efficient way, especially when you were dealing with tons of elements in the scene. So an alternative, which is, in my opinion, tidier, is using exclusive link, or was using exclusive link. And if we hit simulate, we see that it achieves exactly the same result. Problem with this was that we could do things like this, which didn't really make any sense, among other things that were possible and never got sorted using this link system. So that's partly the reason that we moved to a different system, which is the nodes as a relationship to create the scene setup. But I'm going to quickly open also a very complex scene so you understand why we moved to the other. And this is no other than one of the many versions that my colleague Gustavo Sanchez, who is also today online answering your questions, worked on a few years back. I'm pretty sure you remember this one that had a shipwreck, and I think you can see it here. I don't know if this video is going to play all right, but you will remember this one. We had a shipwreck and we had all the nice waves crashing. That was one of the first, actually you see here is RealFlow 5, hybrid of first evolution, and of course Maxwell render. Well, that scene was extremely complex, and you see here that we didn't use global links, we used exclusive links because we needed to keep everything under control. But you see the number of elements that the scene had. It's like tons of elements, tons of IDOCs, which are the ones that we use to send to the job manager and to the farm, all the nodes. But unless you are Victor, and probably Victor itself, he wouldn't make any sense of this scene right now, because it was so long ago that he worked on this scene, and with no reference whatsoever on what's linked with rather than, okay, the grid domain is connected to all these here. It would be really, really tricky to understand what's going on in this scene. And this is probably one of the main reasons why we moved to RealFlow 2013 and open another RealFlow 2013. So RealFlow 2013, you now see that we have changed slightly the interface. You can create your own layout as you wish, of course, but first thing that you notice is that we still keep the nodes tab, but we don't have exclusive and global links. What we have is the relationship editor. If we were going to try and do pretty much the same as we had in that simple example I was doing earlier, we'll have a circle, and you instantly see that we have a node here in the viewport. Can you stop just for a sec? Kevin, is it going all right? No problems in sound and everything fine? Good? Okay, and I continue. Excellent. So let's get back. So I was saying, now that you can simply create a node in the same way as we were doing before by using the top shelf, or we can also hit the tab key and start typing what we want. Like in this case, we will add a gravity, and we have the gravity here. We see here that we don't get anything connected. This is because we didn't have the equivalent to global links selected, which is, or will be, default hat. So if we had that, and we add now the plane, that plane will get linked to a hat, which, as I said, is pretty much the equivalent to the global links in all versions. So if we wanted to have everything in global links, simply drag a line and connect all these three, and if we just save it and test, and we hit simulate, we get the same result as we had in 2012 or previous versions. So it's pretty straightforward to have something working. If we're using hubs, how do we know what is connected with what? Well, if we right-click, there is a show implicit connection here that shows us how things are going. Color coding also helps to know that yellow is for geometry, as we have seen all years in RealFlow. Red are for forces or diamonds, and blue are for emitters, like particle-based emitters. If we don't want to use hubs, how do we do exclusive links between these? Simple, as you may imagine, it's just a simple click. If you want the circle to be affected by the gravity on the plane, and if we reset and simulate, we get again the same result. So nothing magic, still RealFlow way easy to use, nothing really complicated. If we had a complex scene, like we will have, of course, once we start working with the tons of nodes and things like hybrid, etc., there are things that still can help us work. And something that I can't show you right now because we, I forgot to mention, this is a very early version. This is like an alpha yet still, and we're working towards beta right now, but these versions can crash, so I cannot show you because we have managed to break compatibility in those few weeks. and I cannot open all scenes, but you will be able to open all scenes from RealFlow 2012 inside 2013. And as you may imagine, since we didn't have nodes, how will all these scenes come inside RealFlow 2013? Well, they will create the nodes, but they will come a bit mashed up one on top of the other. So we have something here that's called auto layout that simply move the nodes apart. So they are live steady. So we have the nodes one on top of the other, and we just simply tell them to separate, and that's it. So if we had a huge amount of nodes, they will span and move apart, and then we will start collecting them, adding nodes that we can have now, and this, whatever. So we can simplify and make a visual representation of what we have, and add, for example, nodes for our colleagues to pick up our scene, etc. That's why it will also be easier for people that are sharing assets to share, basically. So what else was in here? Okay, we also have a spreadsheet, not in this scene. I mean, it doesn't make much sense to use it in this scene, but if we have a complex scene, we could disconnect things at once or connect them, which can be really, really handy. Sometimes when you have tons of elements, you don't want to do them at once. Also, we can group things, and they will come as a different element, and they will still be linked, or we can simply get them linked. And if we expand this, we see that the two elements are inside. And if we had, where is it? Okay, show. Okay, change these connections. Oh, okay, this is the bag now. Good, move. Nothing to see here. All right, let's move to the next feature before I keep breaking it. RealFlow graphs. We were saying, okay, these were the relationship graphs. So it's like, okay, we basically setting up the scene in an easier way, in a neater way than we used to. But the power of the graphs inside RealFlow are in the simulation graphs and also in the batch graphs. In previous versions, we used to, let me close this one. We used to code in Python or C++ in order to achieve complex things, right? So we access it at the particle level, and we access geometry, and we go to the vertices, and users needed a minimum level of control of Python in order to do that things. What we are implementing now is something similar to visual programming, based in nodes. You can think as the simulation and batch graphs inside RealFlow as something similar to what you have in 3ds Max with thinking particles, in Houdini with blobs, or in ICE in Sofimage. And you can find them here. There are batch graphs in the same way that we had batch scripts. And also we have the simulation flow, which is the old version, old window that we call simulation events, now being renamed to simulation flow. And this is no other than this one that I have open here in this simple example of something similar to a firework. So if I reset that and I hit simulate, we see that there is something going on there, like some particles and some trails. If we wanted to do something similar to this one, which is nothing else but taking this particle position, and as it moves, adding a trail of particles back, we will need to know which functions to query, etc., etc., etc. I have opened from our RealFlow home page. If you go to resources, you know that there is still an old page. We have a really nice new website, but we don't have a new resources site. This is because we've been waiting to 2013 release to revamp this site and kind of adapt it so it can host also RealFlow graphs, the idea is that we will have a community around these RealFlow graphs, and people will be able to share in the same way they were sharing these Python scripts. So I wanted to show you, if we go to the Python scripts and we type trail, we find these trail particles by Jorge Alex, one of our colleagues as well. And I just downloaded it. So you see, probably not exactly the same because it does have, it colors the particles, etc. But it's doing essentially the same, doing some trail particles in here, which will need all this code and half of it. If we go inside RealFlow now, and I can pretty much delete this, that, because I did it a bit more complicated. We could do the same thing that you saw here in that script with these 4 nodes. The way you do that is, let me delete, I hope it does work. It doesn't break for me now. We add the particles, so we type in the same way, sorry, I forgot to mention. In the same way that we added scripts here, we add now the graphs. And as I have one here, I just need to come into the graph window, hit the tab key again, and I start finding my nodes. So I can do get particles, get particle. I come here and I select the meter I want to get the particles from. Then I find the particle channel. Let's say particles to particles. The channel I want to use is world position. I don't want any of the other. I want one position. And then I want to add these particles positions to a different emitter, which is simply container. And then we will need an evaluator node, which is normally the one that closes the chain and executes all this. So if we just simply run this one, it should produce exactly the same result that you saw earlier. So nice simulation with a few clicks and just 4 nodes, 3 nodes that you don't need to know what they are doing underneath. So the power of this is it's going to be amazing, and we are really confident that people will go crazy. We have, I believe we have like over 200 nodes already implemented, and we plan to have way more as on release and as the release progresses in successive versions. And to show you another example that we have here running, let's see if we clear this one. More things that you can do with nodes. For example, I could get some basic. Right. I could use a sign distance field from a geometry that I import, and I'm going to be importing this model right now. Let me rename it. So we have this nice frog object. And what I want to do is to have some particles on top of it from this emitter and get those particles intersecting the actual volume of the frog. So if I put, let's use some particles so we go a bit faster here. If we got all those particles, okay, let me move it. So let's forward. All those particles, we want the intersection with the head, and we want all those particles to be removed. So let me just get rid of this, and I'll show you what's going on in a second around here. Let's save. As I said, this is a an alpha version, and it might go a bit crazy if we don't. What I'm doing here essentially is I'm getting an object, the frog, and querying its mesh, and from the mesh I'm creating a distance field. And distance field isn't nothing but a representation of the shape, but not in the form of vertices and face, but like we could call it like an area around the object, which will help us query the distances from the particles to that shell, so to speak, that hosts the object. So we're going to be creating that distance field and sampling it. When we create a distance field, what we do basically is we create a grid, and we assign values with the distances in the grid from the actual geometry, that is the goal that we want to achieve when we want to create that distance field. And we assign the values of the distance from the geometry outside. So then when we have something that is going to be colliding with the geometry, we just query the position of our particles, for example, in relation to that distance field. So in here we have the standard emitter, and we are linking that to the square. We're getting its particles, and we're sampling the position of those particles with the distance field. And once we have that, we're filtering the particles that are outside and creating a mask. And that will give us the result, which is the particles that are inside the distance field. And those are the ones that we're going to be removing. So if we simply run this graph, now it doesn't crash on me. Let's say creating volume somewhere. Let me reset and run again. All right, this is the demo effect. It's not doing anything right now. Okay, what's going on? This is the frog, it's a square, and maybe I will have this one active. Oh well, something had to go wrong. It wouldn't be a demo if it wasn't. Okay, this was supposed to be cutting those particles, but it's not doing it right now. So maybe I'm going to be running a different example. Let me check, let's get a new one. Faster one, since we're passing half an hour now. Imagine that we have something like this geometry, and we want to emit from them. So I'm going to put some keyframes in here, and some keyframe in here, so it's something like that. Quickly, we want to emit from that geometry, so we get the object, we get the mesh, get the vertices, get the object and its vertices, and now we get the vertex channels. So we want to get the position of those vertices and the velocity of those vertices. Oops, I just duplicate everything. This one. And the position of those vertices. So we create particles on a new emitter. The standard emitter. In this case, we're going to be using a container. So we're going to have that container. Okay. And we're going to add the particles. Actually, we don't need that one. We can do it straight away. Positions. velocities, and the emitter we pick it from here. And then we evaluate. Okay, so if we save this one, mission, and maybe just put the totals, simply hit simulate, we should get a trail of particles being emitted from that object. I think they are liquid, that's why they are not moving away. So this is another quick example, something that isn't difficult, but it will take a bit. And this is not picking up, oh yeah, it is picking up the velocity. It will take a little bit longer to be generated by using Python scripting instead of simple nodes. So you can see here, and I'm going to move to the next topic, the power of using RealFlow graphs inside RealFlow 2013. I'm sorry about the one that didn't work. That was cool. Next one is Lambic. Lambic is an open source format that we have been looking at for quite a while, and it has become, or is becoming, standard right now in the industry. So we decided that it was about time that we implemented it, and we are not doing only Lambic for geometry caches, but also for particles, and that will help quite a lot, we hope, with the hydro simulations, because with Lambic there are tons of things that can be done, like selecting subsets from the files and also compressing them. Inside RealFlow, one can find Lambic if I just simply create a few elements. So we can go to Export Central. We can find Lambic everywhere. So we go to Export Central, and we see that we have Lambic sequences here, where we can select or deselect and only export what we want to export. This is a way of reducing the file sizes. We also have here the compression settings for Lambic. And in this version that I'm running right now, for the grid fluid, we do have GDC format, which was our proprietary format. This is going to be deprecated, and we will only have Lambic caches for Hybrid, together with another open source format that we haven't mentioned here, which is Fill3D. So we will have Lambic plus Fill3D for Hybrid to have its full power, and that will help also integrating Hybrid 2 in other platforms, because it won't need to use our formats, but open source formats. Same goes for RealWave. We also have Lambic sequences, and all the objects in the scene will also have Lambic animation, caches, etc. There will be also tools. We don't know yet if they will go under tools, or there will be command line to combine multiple Lambic files and also to convert between formats. And before I close that, good thing about the Lambic, let me close this one, when talking geometry, is that it wasn't possible before to do something like this. Let me find the models. Where are they? Lambic models. If we had something like this that had multiple pieces, and this is an object that has animation, and we said, for example, oops, I just want the legs, I don't want these bits. We can now delete it. This with our SD format wasn't possible before. Even better, the undo works, something that was a bit of a problem with the old SD file and previous version of RealFlow. Not major, but it was always a pain. And if we wanted to duplicate, we now can duplicate bits, and it will follow even the transform. So Lambic is a cool move for us and for everything that has to be moved from and to RealFlow. Next feature is Maxwell render, and this is also a big one, mainly because this will allow to have background previews in the farm. You don't need now to block your machine when doing a RealFlow preview. You can send your previews to RealFlow nodes in your farm, and that won't cost a Maxwell license. With the RealFlow node, you will get Maxwell inside RealFlow, because we are using just Maxwell Fire, which is the interactive render engine for pre-visualization. We are not using the full Maxwell render, but the one that comes with Fire, which is like a draft mode, so to speak. Another good thing about Maxwell is that it will come with the fluid material presets, and that will help quite a lot when trying to show someone how your fluids should look. A quick example here: if we, for example, create a real width, let's put the camera, so maybe we just need one window. Let's close this one, and we say, okay, we have that real width there. Let's add it statistical spectrum so we get more detail. You will notice now that every single RealFlow object has a Maxwell render tab. And if you come here, you can decide whether that object is renderable or not, and which material it's going to be using. As I said, there will be quite a few presets for materials like honey, chocolate, blood, then we have water, water pure, water ocean. In this case, we would like to use water ocean. And in the case of RealWave, we will be able to use a tiling feature that could help us creating an infinite ocean without having to do anything else. If I hit F6 now, and before I do that, I'll probably have to go to the Maxwell render settings, which are here, and not many. So as you see, easy, simple as always with Maxwell. You just play with intensity, whether you want a physical sky or you want to play some light emitters in the scene. How do you want the day to be, stone, dusk, the quality of your pre-visualization, the higher, the longer it will take to refresh in the interactive, sampling level that you want to achieve, if you want more or not motion blur, and the global scale that is important when you're trying to work with the material that have light transmittance, because if you, this will work correctly when you have the right or wrong scale coming from your 3D platform. It will be a way of adjusting the scale, basically. So right now, if I hit F6, I get instantly that, which is an ocean, but a single batch. If I wanted to tile that out, I could say, let's create 10 tiles by 10 tiles, which is quite a lot. You see that I have created an ocean with just 2 clicks. And let me put the plane underneath so we can see better how this looks. And I don't need to give it any material, but if I hit F6 again, we see that we are getting a nice ocean look in a few seconds. It might take quite a while since we're doing quite a few things right now in the machine, but it gives you the sense and the look and feel of what you're doing without having to send your simulations to a 3D artist that's going to be lighting the scene, etc. So let me just get rid of the real wave and add a simple circle emitter. Let's, for the sake of seeing something different, let's say we don't export anything, hit simulate, and maybe everything's colliding, so it should collide with the plane when it hits it. All right, come on, right. We have it colliding there. Let's get more. Let's get more. All right. And now we create a mesh, and we mesh it up. And before we do that, let's say, okay, the mesh is renderable. The particles, we don't want to see them. And the mesh is going to be honey. If we build the mesh and we hit F6, there you go. That's the beauty of Maxwell inside RealFlow. You get a nice look for your simulation straight away, and you can send these previews, as I said, to the front, to the RealFlow nodes, and that will be great because you will split the time that you take doing your previews by simply send them to multiple machines that will be calculating single frame image or range of frame image, whatever. And Maxwell has the best quality of any render in the market, so you get that almost for free inside RealFlow. So next, let me just close this one. It's Viewport Plus, is how we call the work that we have put into making your experience when using RealFlow and loads of detail and data in the GUI. If I go again and just open RealFlow, actually I think I have it open. It's this one. Didn't need to open a new one. This is a scene I was working on long ago, and this had kind of a stream or a river, and it's loading the cache. It has 31,394 something particles. In any other software and previous version, to do this wasn't possible at all, was it? So this is what Viewport Plus is. It gives you the ability to work with massive quantities in the viewport. Actually, I was showing here only 10% of those. If I go 100%, still moves freely, no problem whatsoever. We have also added not only the percentage, but the ability to display the particles as arrows and spheres. You see here the arrows are huge. Let's say 5. So these are arrows now that may give you a different look. Maybe you want to do a preview, OpenGL preview with that, or maybe you want to go and create spheres. So these are the spheres now. You see. So cool feature, especially because it allows to load massive amount of particles, and it will only depend on the amount of RAM that you have in your graphics card. But I'm running on a graphics card, a very domestic one. I think it only has 1 GB RAM, so this runs pretty fast, especially with coins. It kind of flies, so I don't think we need more than that to be able to work with massive scale scenes. Next feature, and we go back to presentation, is RenderKit 2013. RenderKit 2013 needed to be here because with the amount of detail that we're getting from Hybrid 2, we couldn't allow ourselves not to get new meshing algorithms to keep that detail. And Hector Artal, which is our man doing RenderKit, is doing an amazing job, and I'll show you a couple of examples of how cool the meshes will look. Like this one, you see that we keep all the detail, all the fine detail that we get in the simulations, and we still get flat areas when they do need to be flat. So before, this wasn't possible if we wanted to have this, and vice versa. So a big thumbs up for Hector, because he's also Angel, who is working together with Hector in this one, and they're doing an amazing job in this. And this is another example where you see that when there is a flat area, it is flat. When there is thin detail, you get thinner little here, and totally flat in here. This is, believe me, this is pretty awesome what they're doing here. Right. So this is for Remikit. The Caronte Body Dynamics, which is the body dynamics engine that we have inside RealFlow, and we have decided for this version that we were not going to be putting way too many features. In fact, not many features in it, but making sure that it was way better in terms of speed, stability, and we managed, or the guys managed, to get some fracture enhancements that are pretty cool. I'm going to try and show you something now. We'll try to answer the questions. Okay, where am I? I'm here with the Caronte. Okay, I need to go to the videos. So, Caronte 2013, which is this one. Let's see if I manage to create a loop here. All right. Okay, these simulations, as many of the other ones I was showing, have been created by Luis Miguel, and he really has fun destroying and breaking things. As you see, stability, don't see jittering anywhere. It runs relatively fast. This simulation was 16 minutes something. So something I forgot to mention earlier, and probably could go right now in here, is that as with other things, you see here we added a command line option. For Hybrido, we have added these min-max substeps, which control the stepping of the simulations, and for Caronte, it is down here now. And you see, we don't know if this is going to be 100% the final naming or even set of parameters, but there will be more than this. Quality and anti-jitter is something that make things go to sleep or don't vibrate, and the level of quality that you want. And also forgot to mention way too many things. You see, there are way too many cool things in this version that I keep forgetting, good ones. We also have, for Hybrido, some GPU acceleration based on OpenCL. And if you want to know exactly what we have been doing with that, you can go to NVIDIA website, and Angel Tena did a presentation last SIGGRAPH where he explained exactly how we're using Hybrido on the GPU. You can find your system information, and if it runs with the GPU. This is my graphics card. It has OpenCL 1.1, which is what is needed, nothing else. That. So we were in Caronte. Sorry, I just derailed like that track. This shows the coolness of the new fracturing tools. Pretty much everything is in there, all the new fracturing bits and pieces that Louis has been trying. And you also see that this is using multi-joints, which will be more stable, more robust in this version. And show you another clip. So this simulation had multiple levels of fracture, multiple elements fractured with different types of fracture types. The coloring codes mean that this is based on the stability and speed enhancement that I was talking about. When the pieces are red, and right now this color coding is just in the framework that Luis was using to simulate this, not in RealFlow Alpha yet, so I cannot show you. This means that if it's red, they have full energy, they keep losing energy as they evolve, and then they become gradually white. When they're white, they get taken out of the solver, so solver runs faster. And then if anything interacts with them, again, they pick up some energy, they change color, blah, 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 they go back to red or whatever it has to go. That's how it works. So it's the same simulation from different angles, well, different simulation with just slightly tweaks in the settings, but you see cool little pieces hanging everywhere. So it's very natural. All this was simulated at once. So it's pretty cool. And I could quickly try and break something here. Can I import an object that Luis passed me, which is, let me find it in the desktop, go to demo, spaceship. And this object has a ship and a couple of elements I'm not going to be using, but this ship has quite a few elements that are tweet and everything. That it's an upward shape, and in most cutters or choppers or fracturing tools, it will be tricky to fracture at once. But now, with the Caronte fracturing tools, we can go and say, okay, I want approximately 200 pieces, uniform, done. So if we hide the original one, we come here and change the faces, so it's fractured in no time without a problem. I was talking about different fracturing tools, and if I simply create a sphere, I can leave it there, and I say, okay, I want this ship to have a hole there where the pieces have smaller elements and then gradually grow. So I select the object, I say come here, and by all means this is not going to be the final interface. We're going to work on it, the toolbar for all the fracture tools, but just to illustrate, I could say I want to fracture that ship by geometry using that sphere. I want to concentrate the pieces inside, and this will be roughly the amount of pieces or the resolution that I want for that fracture to have. And I want to split the channels so I can have two objects as output. One is the object that interact with the sphere, or the fracture bits that will interact with the sphere or the sphere area, and the other is the remain of the shape. So yeah, if I simulate breaking happens, I can hide the sphere and the original shape, and we see that where the sphere was, we have created tons of elements, and then these small ones gradually become bigger, bigger, bigger until we get different objects. And as I said, we get two objects. One is that, the other one is that. So these are some of the enhancement that we have put in the fracturing bits in Caronte. So if I close that one, we move to the final feature, which is the licensing enhancement. It isn't out of the ability to have floating licenses for the GUI. This again was an all-time request, especially for those that have multiple licenses and they want to manage them in a centralized way. If you remember the picture that I showed at the beginning with the RealFlow pipeline, looking at the global pipeline that hosts the GUIs, the RenderKit, and the RealFlow nodes. Right now, or until 2012 version, we only had the RealFlow nodes and the RealFlow RenderKits licenses going via the next link license manager. What we're going to do in this launch is to have also the GUI license, but this will be optional. So if you're happy with the way we license the GUIs, you don't need to go via the license manager. But if you think that it's better, and we think that in many cases it will be better, then you can use it via the license manager. And that's all I have to say for now. So Q&A, Kevin, back to you, and thank you very much for listening. We'll try to answer all your questions, and if not today, tomorrow or in the forums, we hope they will get answered.
That's right. Can you guys hear me? I think you guys can hear me. Gustavo, that was awesome. I just want to let you guys know that there's a ton of questions that have been coming in, and we're going to take about maybe 10 minutes to answer them. If there are any other questions that have not been answered, we will do our best. We're going to forward these questions to the Next Limit team, and they're going to answer it, and we're going to post it at our blog at Novedge. So shall we get started? Let's do this. I think I'll start from the top, and I'll assign the questions to you as well, Gustavo. Let's see.
Do I need to talk? I mean, do we want the questions to be answered live or with the microphone? Or
Yeah, we're going to do 10 minutes of answering live on the microphone. Victor and Luis will are answering questions as well. So
Okay, cool.
let's scroll down here. Yeah, see, there's tons of questions. I mean, I have to scroll down, so let's see. Give me a second. There's just so many of them. All right. Here's a good one. I think this one everybody kind of wants to know. When will RealFlow 2013 be released?
All right, that's a good question. Hopefully, the aim right now is to release in Q1. Q1 ends at the end of March, so let's say by the end of March.
There you go. By the end of March. That's pretty close. So if you guys can hang on there, yeah. Well, Novedge will work with Next Limit to carry this. I'm excited. I'm sorry. I'm stuttering right now. Let's see. Here's the second question. Will there be a steep learning curve to learn RealFlow 2013 in comparison to RealFlow 2012?
Not at all. As I was showing, if anything, it would be easier. RealFlow, with the relationship editor, we think that the understanding when you're creating a scene, what's going on, is way easier. Either if you're using Python or if you're not using Python, you don't need to go with the RealFlow graphs to create complex things, but you will be able to, because we will be hopefully having some, we will share some high-level or complex graphs that will do funky stuff and people can see them. Actually, can I show you something, because I forgot?
No, if you want to do a live demo, yeah, of course, yeah, your screen is live, so do what you will to answer these questions. Yes.
Okay, let me just show something that I forgot to show. This is something that one of our colleagues is working in, which is this. I just got this today. This is the real wave being deformed with RealFlow graphs. I think it's pretty cool. It has some, I mean, the statistical spectrum waves, which is basically a Tesson dot displacement, and then some particles sticking to that displacement, and it's using just two graphs to control that and the movement of the swirl. So to do something like this, we will, like in this case, we will have these graphs shared in the community. So hopefully people will share their graphs, and complex stuff that could only be done before by using Python scripting will be done by using RealFlow graphs, and people will share it.
All right. Okay, moving on to the next question.
That answers the question.
Alex, yeah, I think that answers. Alexander wants to know, where can we see the movies? I think this is a good plug for your community as well. Yeah, that's a question for you.
What movies? Sorry, what was that question?
Where we can see the movies. I guess the examples.
The examples are online. Most of them are online already. You can see them either in the YouTube channel. If you go to RealFlow, you go to YouTube at RealFlow Labs, you should be able to see all the examples that we have in there. I think there is a channel that has all the hybrid ones. You see, they are here. And we hope to keep uploading videos pretty soon. So with the new features.
Cool. Let's see. This is from Patrick. He wants to know if there are any improvements in threading with 2013 to more efficiently use the multi-core systems. Thanks, Patrick, for the question.
Yes, absolutely. The new hybrid tool is way better than the old one in terms of multi-threading. You will be able to see your whatever number of cores you have most of the time on top compared to the old one. It always depends on the scene setup, but this one has a way better performance than the old ones.
Let's see. James wants to know, will you be able to open projects from earlier versions into 2013 from 2013 into older versions? So basically from 2012 to 2013.
Yes, it always will go forward. I mean, we will try to keep compatibility going forward. It will be tricky to go backwards. So going backwards will be practically impossible unless you export to XML format and edit the file so it doesn't include the things that were not there. And I'm not 100% sure that will work. But, there might be a chance that works. But coming forward, yes, you will be able to open 2012 inside 2013.
Cool. Paul wants to know, can I modify particle channels individually, such like velocity, position, vorticity, density, etc.?
Yeah, we hope that can be possible with graphs. Yes, the answer is yes.
All right. Will RealFlow 2013 be GPU accelerated?
There is GPU acceleration in the hybrid of flip solver. That's the only part that we have GPU acceleration right now using OpenCL.
Cool. Sean wants to know, will the Learning Edition of 2013 come out at the same time as the standard version? Also, will there be any added limitations with the Learning Edition? So,
No. Not that we are thinking of right now. It will come out at the same time. And actually, we just updated one of the contests that we had in the social channels to make something similar to what we did with the RealFlow Splash competition last summer. So when 2013 comes out, that contest that we had running over Christmas will get back in place for the Learning Edition. So that's
cool.
With Learning Edition. I don't think we're gonna clamp anything.
Gotcha. Yusuf wants to know, you probably can't do this. I don't know if you guys can do this now, but he wants to know if you could render a realistic Hybrudo water material step by step, please. So,
water material, you don't need to worry about water materials. You just get to Maxwell, get the material that we provide, and that will work as water. You can ask Victor Sanchez, he's our expert in RealFlow Maxwell, and it will take 10 seconds for him to create a water material. I mean, the ones that we will provide will probably work. And it's pretty simple to get a working water material. We'll try to have examples on the website so people can download. But the materials that will be included inside for 2013 will be more than enough to create realistic, because Maxwell is realism.
Got it. And you guys can probably find, Victor is probably on the communities too that you guys have there at Next Limit as well, right?
Mm-hmm. Yes.
Cool. Yeah, so you guys can, if you guys have questions there, ask Victor as well and Louise, who are probably on the communities over at Next Limit. Okay, moving on. Let's see. So some of the more complicated questions, we're going to post it at the Novedge blog, and we're going to share the questions and answers there as well. So let's see. Christoph wants to know, are there any efforts to use RealFlow render nodes within the Rebus farm?
We keep talking about using it in Rebus. The thing is, it's tricky to work with simulations that are big in terms of space, this space, because bandwidth is always an issue. So we keep looking into supporting render farm, but it's a tricky issue. I mean, you will probably need a huge bandwidth, or will have to be talking to delivery via, I don't know, picking up hard drives full of RealFlow data back and forth. It kind of makes sense if you render at the same place. So if you simulate and render there, it might be an option, but we'll have to look into that. I mean, we always keep looking into what's going to happen with the render farms. There is more and more cloud services and render farm services, so that is something that we keep in mind.
Okay, let's see. Imran wants to know, will the third-party plugins example, the ones from Wetwork, work for 2012, work for 2013? The plugins are expensive, yeah, so will those third-party plugins work?
They will have to be recompiled, and I guess the guys will recompile it. We keep in touch with these guys, most of them, so that shouldn't be a problem. I guess they will, if you have bought the existing version for 2012, they will give you the updated for 2013. I don't know, because we don't deal with them directly, but I would assume that they will update them for the current version.
Okay, Diego wants to know, I think this is a good one. I'm sure that people want to try it out. Can we beta test the new RealFlow 2013?
Can I beta test it? We don't have a beta yet, but we are still in alpha state. We're close to beta, and we will see what's going on once we have the beta and see if we can open it a bit more. Right now we have some close people that we always work with testing the early versions, but it isn't an open beta, and it will be tricky for us to manage an open beta. We'll see what it can be done. If you can send us an email, we'll talk.
All right, Diego, I hope you heard that live. Send an email to Gustavo and the Next Limit team, and you guys will talk about that. All right, so Robert wants to know, will there be a plugin for Lexology Moto 601, or will it be Lambic interchangeable?
Lambic interchangeable, for sure. I don't think we need to make, one of the reasons for implementing Lambic is trying to use as much as we can open source format, so the interconnectivity between any platform becomes easier. So we don't need to work, I don't think that we need to work on a model-specific plugin, but try to make sure that whatever Lambic they have in place work with ours.
Cool. And then last question. Okay, I hope this is a good one. David wants to know, are there any plans for a Python-based job manager submitter?
The job manager is Python-based. So you can, there is an implementation. If you, I don't know if it comes with the installation, or we do have the code and we share it, but I'm pretty sure we have a wrapper that is based in Python. So you can use your own job manager by using the Python wrapper, if that's what he's asking. I'm not sure.
All right, guys. In that case, that ends our Q&A session, and there are a lot of questions that have been posted and forwarded. Not even Victor and Luis can answer all of them, but we will take time after the webinar to post them at our blog at Novedge, and you can also find these answers too as well on Next Limit's online community. So check that out, okay? All right, so moving on. Gustavo, I'm going to switch presenter to me right now.
Okay.
Cool. Let's see. Change presenter to, actually, give me a second here. All right, can you guys see my screen here?
Yes, we can.
Awesome. Cool. So thank you so much, Gustavo, from the guys at Novedge. Thank you also Angel, one of the developers here, Victor, and also Luis for showing up and answering the questions that we have. Thank you guys for joining us and hosting this webinar with us, and thank you the attendees for registering and signing up and showing up today. So for more information about Next Limit Technologies, RealFlow 2013, which is coming out in March, visit their webpage at realflow.com. RealFlow 2013 gives you the abilities to create large-scale fluid simulations that will match any on the market straight out of the box. So with RealFlow, you don't need to be a software programmer to set up a fantastic simulation. Just choose your settings and you're ready to go. The latest version of RealFlow 2013 gives you an unprecedented level of realism with the power to control and customize every aspect of your scene to get exactly what you want. More information, go to RealFlow for sure. Check it out there. And as the leading online software design store, we pretty much have the best prices around. RealFlow is available from us, the latest version right now, 2012, as a digital delivery to the United States. In addition, you could pay zero sales tax. Feel free to contact our sales specialist, Bob at novedge.com. And if you have any questions about RealFlow 2013, please forward them there. And we're going to be working with Next Limit to make sure that RealFlow 2013 is part of our latest catalog as well. Also, if you have any questions or you want to be part of an online discussion, we have an online place, 3 online places exactly, WikiCAD, Vector Working, and Rhino Jungle. You could join one or you could join all of them. Not only are our communities a place to discuss the latest industry-related news, it is a community where even the developers show up from time to time to answer your questions. Don't miss this opportunity to interact with other like-minded professionals. Signing up is a breeze, and with that you have access to a weekly community newsletter. For access to discussions that matter, register today. I also want to mention that if you guys have any questions or concerns, want to throw some feedback to us on ways we can improve Novedge's webinars and what we're doing, feel free. Don't hesitate to email me at kevin@novedge.com or bob@novedge.com as well. And here's a plug for the upcoming webinar, the new Cinema 4D R14 features hosted by Paul Babb. You get a sneak peek at Release 14's powerful new features, from fast and intuitive sculpting tools, enhanced dynamics, new camera tools, and many others. Whether you're a visualization artist, motion designer, illustrator, or animator, you'll find something to love about R14. Maxwell President and CEO Paul will be here to present this upcoming webinar live and to answer your questions. This is an excellent opportunity, and sign up, register today at novedge.com/webinar/63. And also, to answer some of the questions here, some people kind of left early. If you want to rewatch this webinar, you can, and all our other previous webinars, you can check it out at Novedge Webinar Series channel through Vimeo and YouTube, so stay tuned over there. Subscribe. Lastly, follow us on Twitter by our handle at Novedge Store, where we'll share with you the latest buzzworthy industry news, trends, and promos that we are offering at Novedge. Join the conversation and follow us today. And on behalf of the team at Novedge, I want to thank you guys, and ciao. Gustavo, do you have any last words?
Hey, sure. I just want to say that it's a word for the guys that are working very hard on RealFlow 2013 to make sure that we deliver by, as I was saying, end of Q1. I wanted to say a big thank you to Angel, who's the head of development, Luis Miguel, Alex, Enrique, Hilco, Victor, also the Caronto team, Nuria and Agus, and on behalf of all of us, thank you for watching, and we hope that you are waiting for the best RealFlow ever. And thank you, Novedge, for having us today here as well.
Thank you, and thank you guys for signing up. All right, we'll still be live, so stop recording now.